Dog Gadgets. Live.
There we go.
Happy Wednesday. It's Wednesday, right?
Wednesday.
It is Wednesday. Happy Wednesday. Hi. As always, I'm Josh from Brown Dog Gadgets, and to my right over here is the disembodied hand of Pete Prodell.
That's right. Look at that. Oh, he left a comment.
Yes, indeed. Oddly enough, our viewer has the same name as our producer, Pete.
Weird.
Great one, Pete.
Thank you.
But today we're making another fun paper circuits project, but we are using the magic of transistors.
Yeah.
Need like a xylophone, like doo-doo-doo.
Josh,
You know.
I can't help but notice you have hair. You know who doesn't have hair?
Who?
This guy, Bald Engineer, who said, great intro.
Bald Engineer.
Yeah.
We appreciate you
he's got
and
no
your
hair in
timeliness and your wonderful profile.
Comment is
picture.
spot on.
I mean, we thank our video guy.
Have you ever seen his stuff? I'm pretty sure I've seen his website and used some of his like code or Arduino instructions before. So I'm just
I don't remember. It's all a jumble up here at a certain point.
All right. Well, thanks for joining us.
Thanks. Look at that. People actually commenting.
Hooray.
So anyway, yeah, we're gonna make another fun transistor circuit like we did yesterday. Using paper circuits and fun stuff. It's a great kid activity to do, great adult activity to do. It's transistor based, which is kind of funky and cool on paper crafts and all that fun jazz. You can find this template and far more activities all for free on our website, browndoggadgets.com. Yay! We always put our educational resources, all of our diagrams and whatnot up there for free for anybody. Whether or not you like our stuff or you like us, you can still use our resources there. We won't bother you too much about
Who
it.
wouldn't like us? Come on. We're adorable.
I've got
Look
a
at
short
this
list of
tape,
people who
maker.
don't like us. So
Maybe you. Everyone loves me.
it's true. Everyone loves Pete. Yeah, he was the inspiration for the TV show Everyone Loves Raymond, but it was really about Pete.
Yes.
My dog is groaning at that bad joke. He's below the desk here. But anyway, if you like our stuff and like what we're doing, you can find more of our stuff at all these social media spots: Facebook, YouTube, Twitter, Instagram. We post things up there like this project when we do them, and we'll eventually show everything on our live stream at some point. But
Yeah.
you can't see all the new stuff popping up all the time.
It's true.
Hashtag maker tape because
You
we love
got
our
it.
tape. But anyway, let's delve into this wonderful transistor circuit. Overhead view.
Ooh.
If you're a regular watcher of our awesome program, you might have seen yesterday that we made a really great dark detecting circuit with a 3N2904 through a 3904.
3904 NPN says right on
Yeah,
the
there you
sheet
go.
there.
I can read. 2N3904. There we go. NPN transistor. Yay, part of a series of projects we made for some summer camps we're working with right now. And a lot of people who are doing distance learning. So we're like, how can we do bigger, better projects for especially middle schoolers and high schoolers who want to do some more adult electronics projects,
Yeah.
but still want to do it in a format that is inexpensive, kid-friendly, and honestly easy to do at home. Because that's the big one. If you're stuck at home and you've got remote learning, this is easy.
Yeah.
And also, we got a lot of teachers like to do this and show this stuff off. This is a great demo activity and project. This works pretty well, although, as we mentioned yesterday, this is a super inefficient circuit. So our battery is already dead from yesterday, which is why this is not turning on, because it's super inefficient.
But you can swap out the battery fairly easily.
Yeah, totally could.
And that's because we just left it running since yesterday. We forgot to disconnect it. That's
We have so many like half-dead projects around here, just shelves them. So this is another project we're doing. This is a basic kind of capacitive touch type circuit using the 3904 NPN transistor, a resistor, and an LED. On the backside, we have one of our transistor legs here. That's our base. If you hold onto that and touch and keep your other hand kind of over here, touch another part, you can trigger that transistor to let power flow through it, and you're good to go. As I mentioned yesterday, if you want to learn more about transistors, go somewhere else, because transistors are really cool. Not us. We do not have anything bright up on transistors. They're really fascinating little things. They really totally are awesome. They change the way we do electronics. Yeah, to no end.
They're the reason we have radios, right?
The reason we have like everything. Like, all those.
They're kind of the precursor to the semiconductor, the integrated circuit, aren't they?
They are. They are.
Go.
And if you ever a chance to do some research on the history of it, just like the original transistor was this like large, like physical thing. It was like this large, like crazy hanging. Yeah, it was like that became this, and that became the 3.5 cents this cost us buying only like a couple thousand of them. But yeah, these guys are pretty awesome. But we're gonna make this simple circuit. It's a nice little project show off. Like our curriculum writer Andy calls it the magic trick. You're like, oh look, I can just touch here and it activates the circuit. Now our battery's you can kind of see the red LED going off a little bit here. Battery's not been on this project for a while. So we're gonna make a new one up over here using these components and some of our awesome, as
Maker
always,
tape.
nylon conductive maker tape. Wow, Pete, you're really on top of that, aren't you? With the
Maker tape.
our maker tape is pretty cool. Bald Engineer, if you want some free maker tape,
Yeah.
call us. I'm not kidding. We give out samples of these to teachers nonstop. It's our nylon conductive tape. It makes things so much easier. Screw copper foil. That's why we're able to do much more complicated projects, much more just physically complicated as well, not just electronically, but physically interesting, three-dimensional shapes and whatnot. Copper foil just doesn't cut it.
And you can remove it.
Well, from
Unlike
smooth
Copper
surfaces.
foil. Well, unlike copper. Yes,
You
unlike
put this on a
copper foil.
window, you can peel it off again really easily. It's not really reusable. It's just forgivable. When I do it with Legos, I call it forgivable. Like, oh no, I kind of screwed up.
Yeah.
We'll just peel it off again. The adhesive just, over time goes bad. Or you can just overlap two pieces because it's conductive on top and bottom. So take that, copper foil. You horrible, horrible, horrible substance. So anyway, we're going to start on doing this little project.
Maker tape.
And it's only Tuesday. So grab your transistor.
It's Wednesday already.
It's a Wednesday. Grab this little transistor, dude. You'll see there are 3 legs on there. You want to bend the outward legs, the 2 outside legs outward. And then this other leg was actually going to go through our cardstock piece of paper here. So you've got and actually label in here, emitter, collector, and base is the middle. And the big issue is with this, you always have to wait for that base to drop.
Yes.
I hear that's the thing kids do.
Hold on, I have a sound for that.
Sad trombone.
I did crickets, but we can also do sad trombone.
Pete loves his little
It's my favorite
controller
thing.
pad. So anyway, so you have to line these up. Transistors also have a flat side that we actually have it labeled here. You have the flat side and the curved side, so you know which one is front and back. I always describe transistors as a gateway you can use to control power flowing through a circuit to kids, because that's the easiest way to explain how they work for the most part. When you see stuff like this, usually in a outdoor garden light or like simple circuits around you, it's often in that kind of basic logic gateway, I guess you call it, logic gate. Yeah, it's reacting to something changing by opening and closing a gate. And yeah, that's the easiest way to explain it to kids. Should have booked the explaining transistors to kids.
I know. Josh, do you know what MOSFET stands for?
No?
It's a metal oxide semiconductor field effect transistor.
We need like the more you know overlay with the sound effects.
So it's basically like a bigger transistor that can handle more current, more voltage kind of thing.
Cool beans.
Yeah,
Well,
it's
the first
a
thing I'm
cool
going to do
beans.
here, I'm going to take this project. I'm going to poke a hole through here. We're using like heavy cardstock because it looks nicer on camera. If you're using 8.5 by 11, this should be really, really easy. If you're having issues, use like a safety pin or a paper clip or something to poke a hole through like heavy cardstock. It just makes life easier. Now, as a fairly average adult, I have no issues, though we have a lot of teachers complain at teaching conferences that they have a hard time poking LED legs through cardstock. So
Yeah.
we make this recommendation for them. Anyway, pop that in. Yay. We got our parts here. And last thing to do is our LED here. LEDs, as always, have a long and a short leg. One is positive, one is negative. You can tell because one's always complaining.
Ooh.
But boom.
Wow.
Yeah. I like to bend the end of my positive leg here over so I don't
Yeah.
forget which one's which.
Yep.
Because I always do.
Always forget.
And that's going to go right here. And then we just have to throw down maker tape. We got a resistor, but it doesn't have there's no positive negative on the resistor, despite the fact someone's argued with me about that. That and wires. I did not get any. I only got 2 negative wires in my kit.
Wires have
Because there are 2
polarity?
black wires. Actually, there's one
Wow.
long black wire that cut in half. to
Color
make the
does not
project.
define the.
And someone complained that they had no positive wire or something like that. It was just like, there's only one color. I'm like, sir, it's just wire. It's just copper. Well, no, I have to have positive and negative. I'm like, gotta be one of those days.
Oh, Josh.
Anyways.
Josh, fun fact. With often Chinese laser cutters will have the ground wire being like yellow, and the positive wire will be like green. You know, I think this is, I don't know, someone mixed it up once and they just do it that way now. I'm not sure.
For the colorblind people in the audience, like myself, probably mostly men. That makes me so happy. So I'm just going to run the tape over
Wow.
my LED leg here because our maker tape is conductive on top and bottom.
That's a transistor. Or that's a resistor.
I'm a
right?
resistor. My bad.
Do we know what anything is anymore?
No, it's not. I'm not a coffee drinker. I just drink my Dr.
How many ohms is in that resistor there?
That is a 4,700 ohm.
Or is it 4.7K? Is that how
Yes.
you might also say it?
I like to put 4,700 because it makes it sound larger.
It does sound huge.
It's like when they have like, how many milliamps is in this? Oh, 10,000 milliamps. I'm like, you mean 10 amps? It's 10 amps.
Yes.
It's like, things in Japan. Like, oh, no, it's 1,000 yen. I'm like, that's equivalent to $10. It's really, the yen's a penny.
With that many amps, you could put on a heck of a concert. You know what I'm saying?
That's where we could drop the bass.
Yes.
Marketing. So we're just gonna do the same thing. Come up and over here.
Whoa, did you just angle that tape 90 degrees?
Yes.
Wow.
I sigh because we have made these like whoa observations way too many times in this live stream because people watch and we're sorry. We're like, oh wow. So yeah. Anyway, we did that. Ta-da! Maker tape. We would be the worst at Sesame Street. Today's episode is brought to you with the letter K and maker tape.
M for maker tape.
Maker tape.
If we have any questions or comments from the people watching the stream, we can take those at this time.
Yes, you probably came to us
Or
because
anytime.
we shared this with a Facebook group,
Yeah,
and that we've yet to be kicked out of
That's
from
true.
sharing live streams.
we share these. These are free resources.
Yeah,
we're
literally,
sharing,
like we're sharing
right?
free resources. You
Yeah.
don't need to buy anything from us. In fact, like we don't sell transistors and resistors, and they come in a couple of our bigger
Yeah.
kits. But if you want to buy these, digikey.com, or we bought a nice big, like a little organizer packet case of transistors just to have around.
Right.
On Amazon is like $10 for this, like maybe 10 different types, nicely organized in a little case. And
Yeah.
I think this actually came from that because our ones we have in our kits have like a little more like pitchforky legs than these are just straight down.
And we could, our templates will show you kind of what you need.
Oh, yeah,
They have
it's
a list of
a list on
components
there,
and
so
stuff, and
just
people can always find those, or if they want some custom kit, we might be willing to do that.
Oh yeah,
too.
we do that all the time for summer camps. And that's why we had a bunch of these transistors around and making these projects because they want to do something a little bigger for a camp.
Josh, we have another comment here, question actually from our friend Bald Engineer.
Ooh.
Oh, look at this one. You'll like that one.
Oh, Bald Engineer. Now that's I'm doing the thing where people say that's a good question, even though that's actually a really weird thing that we in the English language like to say when somebody asks a question and we need a second to think. So that's a good question because it just gives a second to think. Whether I actually think it's a good question or not. But that is actually like legitimately good question. We made a video and posted this on YouTube, Bald Engineer, where we use both our 1/4-inch maker tape and our 1/8-inch version of this tape, as well as copper foil, and compared how much resistance they really had per inch and how much amperage they could handle. We had a little power supply, like 30 some volts up to 3 amps. And our 1/4-inch tape, I usually say like amp to amp and a half, you're okay. It might feel a little warm at an amp and a half, but past that, when you can get to 2 amps, like you can tell like there are hot spots on there. We had a little thermal camera we used as well.
Yeah.
It's not so much that the tape can handle it, that there's little imperfections in this woven material. And we run our finger across like fine. Ow, that really like a hot spot. And we even found when we get to a certain point, like about 2.5 to 3 amps on the tape, you could actually see like where those hot spots were showing up on the thermal camera. And now the tape didn't start on fire. We tried. We actually like literally, if you do the right things in the right order, you can get the tape like to like spark up for a second, like a little tiny flame, like matchstick type flame at a hot spot. But what most likely happened, like 99 out of 100 times, because as soon as you got the camera rolling, we couldn't make it happen again. Those hot spots would literally just break the tape down in a straight line.
It's like a fuse, yeah.
Especially our 1/8-inch tape, because how thin it was. We had actually like little alligator clips like half an inch apart from each other on the tape, and then like crank the amperage up slowly and get it to heat up. But it handles 1 to 2 amps, a really amp to amp and a half. You're a-okay. Above that, I'd be worried. But since everything we do is AA, AAA coin cell batteries, I mean, even throwing an amp through there, nothing happens, and we're good. But thanks, Bald Engineer.
Okay, he's got a nice. This is my LET light emitting tape.
I kid you not, we had like a little meat thermometer I brought in and a thermal camera. The video is kind of fun to watch. We have a short version, like the super long version, which no one has watched on YouTube. But it's kind of interesting to see that versus a copper foil, which is just pure copper, although thin. We would crank it up all the way, and it was still room temperature. Like there was nothing that went on, but you could see like the tape at a certain point, like it got a little hotter,
Right.
and then those little flare-up spots were like, oh yeah, it's just fine. Like, oh, son of a gun, I touched like a weird hot spot. And the same issue you have with nylon conductive thread, where it's imperfections in there that cause that issue. You get like just a little spot of extra resistance. That spot flares up, as in any large circuit you might have. A small spot of resistance can generate a lot of heat. But it's just really interesting to see that because people ask that question every now and then. And I mean, we've run a lot of power overall through our tape. We did a DIY speaker a while back, a couple of videos on that, where we'd have a little amplifier hooked to tape making a speaker, and that could get a little hot. But again, it at a certain point, like it fuses itself out.
It's a safety feature.
It is. So what I did here was I put a loop of tape on the bottom of my battery to connect it here because it's conductive on top and bottom. It's a great way to make a battery holder without using a fold-over binder clip method, which we used to do in a lot of our older projects till we started using our wonderful maker tape, and we realized we can just do a little tape loop for an instant battery holder somewhere. It's a really simple concept for kids to understand too. Although the nice part about doing the like fold-over method, and get this off. That's why I can't play piano. I cannot talk and do something at the same time. I have to.
I'll just remind everyone that we're here streaming every week, usually 3 days a week, 4. I don't know,
3-4 days
a week.
Like Friday, we always have like this is the stuff we haven't done a video on. We've been working on.
Our hangout.
Check out this weird stuff we're doing. We try to have like an interview on Thursdays. Bald Engineer, you want to come on and show off a project on Thursdays. We just like people we know in the maker community, other small businesses, especially in the STEM ed market, because it's kind of a small industry. Showing off projects they're doing. A lot of these companies we've done work with, or we just hang out with at teaching conferences and maker fairs. So we like to bring those people on. So anyway, there you go. There's a circuit. I ran the tape over the top here. I have a connection on top from this and a connection on the bottom from the tape loop that I did. And if you want to turn this off, by the way, you can just peel this over, which is my easy way of turning it on and off. Ta-da! And then put it back on, and that'll last quite a large number of on and offs on there. So with any luck, I touch here and I touch here. Yep, there's my LED is going on very dimly. Yay!
Now hold on, you're telling me
fingers on the bottom here.
You built a circuit. You didn't use a soldering iron or any heat shrink or any wire. How was it magic? What is this?
It's a series of tubes, Pete. Series of tubes, Bald Engineer.
You know what it is.
So that's this project.
Yeah. Maker tape.
I'm a big materials person, and as a former middle school teacher, for me, a successful project highly depended on what materials I gave my students. And even as an adult, I found the right tool for the right job kind of situation, which has always frustrated me with, say, like Instructables, a really cool project on Instructables.com, but it only worked because that person had like some really weird, unique thing like this. 1974 motor out of this specific thing he used. It's really tough. I know that's a big turnoff for a lot of people. Like, I don't have these tools, I don't have these materials on hand, especially weird, specific things. So for me, having a certain set of supplies, especially for kids, I know is going to work 99 out of 100 times with zero problems, is a big thing for the kits we build and the projects we make. Just because we want to have people have a successful time, and especially when dealing with children, which I know if you're probably watching this, you probably are an educator because that's who our main audience is. Like, we want the big thing with these projects are we want to build confidence. Like, yes, you can do this. It's not magic. You can master this skill, and it's going to work for you. And if they had difficulties or issues with the breadboard, which I always did in my classroom, those issues tend to dissuade kids. Like, it's too much work. It's too tough. Even as adults are that way. Like, you hit a roadblock. Like, I'm done for the day. I'm going to have a beverage and watch some TV. Yes. Thanks. What sound effect, Pete?
Applause.
Oh, yay. Anyway, I can't hear it. Don't have headphones on. But so this kind of stuff is a great confidence builder. So stuff like this, we have a dark detecting circuit. We have like a moisture sensor that our curriculum writer Andy also made. Very similar idea with this exact same project. And a cup of water turns on. Simple solar circuits we've been doing, like this guy here. Super, super, super easy. This is a workshop that kids are actually running right now in Ohio with a bunch of our kits. But just simple circuit, blinking red LED, little solar panel. instant access. They see how it works. They understand how it works, and it's going to work for everybody. That's kind of our big philosophy when it comes to building projects and kits, is building confidence, building success, so that people can move on to bigger and better projects, not feeling that they screwed up, like, it's too tough for me. And I saw that in classrooms, like kids, they can't get something going right away. If they run into roadblocks, they shut down, especially a certain number of kids too. Like there's certain kids in your class who are going to shut down with any sort of difficulty. You want to make sure you can build up that confidence in them, or at least show, it's really easy to fix this. You have the tools to figure it out on your own. So that's us. Oh, there's another question I see. It's a
yes, Walter has a comment here for you, I think. A speaker. I mean, usually I just kick my foot and there's a dog bark, but...
Oh, he doesn't bark. He groans. This time of day, he's groaning. Walter, that'd actually be a really good project. Actually, that's something we could do. Little speaking of a dog bark, you could do that with, say, like a programmable board, like an Arduino or a microbit, probably. Just kind of depends on how do you make that dog sound effect, like playing an MP3 file, which is, we do it all the time. That's a little more difficult with the hardware involved, but you can do like a little piezo speaker sound effect. But replicating a dog bark would be...
I mean, we have a sound wall at the end of the...
We do. By the way, if you look back through like our Instagram and Facebook feeds and whatnot, we actually have like a sound wall. It's a bunch of different graphics, vinyl cut graphics on the wall, hooked up to one of our programmable boards, and a little cheap MP3 module.
And
a lot of maker tape going from those vinyl spots over, but it's a capacitive touch. You touch it, it plays a sound effect, and we switch it out every week or so.
Yeah.
Right now it's a bunch of musical instruments with little riffs on them, different types of guitars, drums, a keytar, because you can keytar out.
Yeah.
But that's a good way of doing it.
So you're
just
saying
like the greeting cards?
Yeah.
I would say almost take apart a greeting card. Like that circuitry is really nice on the inside of greeting cards. I know that not the first to recommend this, but I've seen other teachers where they get old greeting cards or even just like super, super cheap ones from like dollar store or whatnot, and they'll take the circuitry out of there and add it to a different project. Because that amount of circuitry, building it by hand yourself is really tough to do because of the specialized components in there. And the cost weirdly goes up quite high, even though it should be cheap and easy due to just economy of scale. You know, they're making a million cards with the exact same hardware on it every day.
Yeah.
You're building one. And that's that weird economy of scale aspect. Even like solar panels too. Little solar panels are weirdly expensive considering big panels are really cheap these days. Just economy of scale.
If you ever need to get a teacher a greeting card or a Christmas card, birthday card, always get them a sound card, you know, because then they can reuse it in their class or something.
Yep.
Do something fun with it.
And that's always the fun thing to do. And there's some good resources out there to do that. We've never done that in shop, but I've seen lots of tutorials where people, especially teachers, have done that in a classroom setting. The hard part is just finding inexpensive cards like that.
Yeah. But
like these days, eBay, getting some cheap stuff from like China directly. Here's a bunch of old secondhand cards. And even our little solar panels we use are, I'm pretty sure, are factory seconds from our supplier. Because I've seen the exact same panel in outdoor garden lights before. Like that is our panel to the letter. Like it's identical shape and size, and we're probably just getting factory seconds from the massive runs they do from our one of our suppliers, and it makes things cheap and easy. But anywho, that's our show for the day. Pretty simple circuit here, but it's a fun little transistor circuit because transistors are always a tough one to do in a classroom. It's magic. But yeah, check out the other couple of transistor circuits we threw up there. The dark detecting one is probably by far the most interesting one. BrownNowGadgets.com. We have curriculum resources up there. Andy, our curriculum writer, even wrote a little bit of explanation what's going on down here on everything and how it all works. He always tries to do that if you haven't written a full lesson for it. But also like 5 days of just full-on basic circuitry on paper crafts, which has been a nice thing. Just if you're a kid at home or a teacher wanting to do remote learning, here's 5 like half an hour, 45-minute lessons on just like circuitry using an LED, a battery, and some paper, essentially, to do different things. I think the hardest thing is making like, you have like a switch with a paper clip. Like, ooh, back and forth. Ooh, I know Pete made up that nice diagram. But anywho, questions, email us. We're around. Call us. We're always here. But we'll be back tomorrow. We really should finally get it. We actually have a speaker. I keep saying we're gonna do that speaker project, but a little bit of extra setup time, and it's like, oh, we have 10 minutes before we're supposed to go live stream. We should get a project together.
Let's get it ready when we're done here today. So next time.
We got that meeting tomorrow, though.
Okay, never mind.
I got a meeting actually off-site. Weirdly enough.
Let's get it ready next week.
Next week. I'll actually make a schedule next week, and maybe we'll get a guest in.
Right.
Maybe Bald Engineer would come by. Bald Engineer.
Who knows? And Maker Block might be good for next week too.
Yeah,
So
it's
we'll
usually like
see.
we totally would have people in. I mean,
Yeah, we want makers to show some cool stuff.
yeah, you have to use our stuff. I mean, don't care. We get Matthew from Squishy Circuits back again. You probably have some fun squishy projects.
Sure, he squished some things. Yeah.
So anyway, cool beans. We're out of here. Thanks everybody.
Okay, and we'll give some
applause.
Edit.
Thanks for watching. Please visit browndoggadgets.com for parts, projects, and curriculum. Follow us on social media at browndoggadgets. Check out our live streams at Facebook, YouTube, and Twitch. We'll see you next time.